Hey everyone, and welcome back to the channel. Have you ever found yourself needing to handle unique items in your data or wished you could perform mathematical operations like unions and intersections directly in your code? Well, get ready to unlock the power of Python's set data structure. In this video, the first part of our set series, we're going to dive into what sets are, how to create them, and all the fundamental operations you can perform. By the end of this lesson, you'll be able to efficiently manage unique data and solve common programming challenges with ease. Let's get started. So what exactly is a Python set? Think of a set as a special kind of collection, like a list, but with a super important rule. Every item inside a set must be unique. That's right, no duplicates allowed. If you try to add an item that's already there, the set simply ignores it. Another key thing to remember is that sets are unordered. This means the items don't have a specific position or index, unlike lists or strings. This uniqueness and unordered nature makes sets incredibly powerful for certain tasks, especially when you need to quickly check for membership or remove duplicates from your data. Now that we know what sets are, let's see how to create them. There are a couple of common ways. The most straightforward is using curly braces, just like dictionaries, but without key value pairs. Creating an empty set. My empty set equals set. Print empty set, my empty set. Creating a set with elements. Fruits, apple, banana, cherry. Print fruits set fruits. Notice how we used set for an empty set. If you just use curly braces by itself, Python thinks you're creating an empty dictionary, not a set. So for an empty set, set is your friend. You can also create a set from other iterable objects like lists or strings using the set constructor. This is super useful for getting unique items from existing data. Creating a set from a list. Numbers list equals 1, 2, 2, 3, 4, 4, 5. Unique numbers equals set numbers list. Print unique numbers from list, unique numbers. Creating a set from a string, unique characters. Text equals hello world. Unique chars equals set text. Print unique characters from string, unique chars. See how Python automatically removes the duplicates when converting from a list or string? That's the power of sets in action. One important point to remember is that while the set itself is mutable, meaning you can add or remove elements, the individual elements within a set must be immutable. This means you can store numbers, strings, or tuples, but not lists or dictionaries directly inside a set. If you try to add a mutable object, you'll get an error. This will cause an error. My set equals 1, 2, 3. Print my set. If you uncomment that line and run it, you'd get a type error because a list is a mutable type. Just keep that in mind when choosing what to put in your sets. All right, let's talk about the basic things you can do with sets. First up, checking if an item is in a set. This is super fast and efficient with sets thanks to their internal structure. We use the in operator just like with lists or strings. My set equals apple, banana, cherry. Print apple in my set, apple in my set. Print grape in my set, grape in my set. Next, adding elements. We use the add method to add a single item. If the item already exists, add simply does nothing. No error, no duplicate. My set, add orange. Print, after adding orange, my set. My set, add apple, adding an existing element. Print, after adding apple again, no change. What if you want to add multiple elements at once? That's where update comes in handy. You can pass it any iterable, like a list or another set, and it will add all the unique items. My set, update, grape, kiwi, banana. Print, after updating with a list, my set. Now, let's look at removing elements. There are two main methods, remove and discard. Both do pretty much the same thing, but there's a crucial difference you need to know. My set, remove kiwi. Print, after removing kiwi, my set, remove mango. Uncommenting this line will raise an error. Print, after trying to remove mango, my set. If you try to remove an element that isn't in the set using remove, Python will give you a key error. This is often what you want if you expect the item to be there and want to know if it's missing. But sometimes you just want to make sure an item isn't in the set and you don't care if it was there in the first place. That's when discard is perfect. My set, discard, orange. Print, after discarding orange, my set. My set, discard, mango, discarding a non-existent element. Print, after trying to discard mango, my set. No error, no change. See, discard just silently does nothing if the item isn't found. Choose remove when you expect the element to be there and want an error if it's not. Choose discard when you don't mind if the element is missing. Finally, we have pop. This method removes and returns an arbitrary element from the set. Remember, sets are unordered, so you can't predict which element pop will remove. It's useful if you just need to get any element out of the set. Popped element equals my set.pop, print popped element, print set after pop, my set. If you call pop on an empty set, you'll get a key error. To really cement the difference between sets and other collections like lists, let's look at this simple diagram. Imagine you have a list with items A, B, A, C. As you can see, a list holds on to every item, including duplicates, and keeps them in a specific order. Now, if you take those same items and put them into a set, something magical happens. The set automatically identifies and removes the duplicate A, leaving you with only the unique elements, A, B, C. And notice they are no longer in a specific order. This visual really highlights why sets are your go-to for ensuring uniqueness and for fast membership checks. All right, let's get our hands dirty with some live coding. A very common task in programming is dealing with duplicate data. Imagine you have a list of user IDs from a survey, and some users might have accidentally submitted multiple responses. You need to find out how many unique users participated. Sets are perfect for this. Getting unique items from a list. Survey responses equals user A, user B, user A, user C, user D, user B. Print original survey responses with duplicates, survey responses, unique users equals set, survey responses. Print unique users from survey, unique users, print number of unique users, len unique users. Look how simple that was. Just by converting our survey responses list to a set, all the duplicates are gone, and we instantly get our list of unique users. Then we can use len to count them. This is far more efficient than writing a complex loop check for duplicates manually. Now, let's simulate building a set based on some operations, perhaps from a game inventory or a list of enrolled students. We'll start with an empty set and then add and remove items, observing how the set behaves. Building a set interactively. Game inventory equals set. Print initial inventory, game inventory. Add items. Game inventory dot add sword. Print after adding sword, game inventory. Game inventory dot add shield. Print after adding shield, game inventory. Game inventory dot add sword. Try to add sword again. Print after trying to add sword again, game inventory. No change, still unique. Game inventory dot update potion gold sword. Add multiple items. Print after updating with potion gold sword, game inventory. Remove items. Game inventory dot discard shield. Print after discarding shield, game inventory. Game inventory dot discard axe. Try to discard non-existent item. Print after trying to discard axe, game inventory, no error. What if we use remove for a non-existent item? Uncomment the line below to see the error. GameInventory.remove key. Print after trying to remove key game inventory. As you can see, when we tried to add sword a second time, the set simply ignored it. That's the unique nature of sets at work. And when we used discard for axe, which wasn't in our inventory, no error occurred, which can be very useful for robust code. If you uncommented that remove line, you would have seen a key error, just as we discussed. Remember, each lesson has related resources like code snippets, a challenge exercise, a quiz that will be assessed automatically right after submission, and will show the result and key takeaways available in the video description. Make sure to check them out. That wraps up the basics of Python sets. We've covered what they are, how to create them, and the fundamental operations. If you found this deep dive into Python sets helpful, give us a like. Got questions or your own neat set tricks? Drop them in the comments below. We love hearing from you. Don't forget to subscribe so you don't miss the next video in our series, where we'll unlock even more powerful set operations. And if you know someone who'd benefit from mastering unique data, please share this video with them. In our next video, we'll dive into the truly powerful mathematical operations you can perform with sets, like unions, intersections, and differences, and apply them to a real-world project. Don't miss it.